We've mentioned that we don't have to type our own variables when we initialize them with values, but we generally should when we just instantiate them, just to make TypeScript's job a lot easier. So for example, if I write a variable just let b and a colon to terminate the line, hovering over it just gives the type of any. So we can use this variable however we want, which is definitely not the way to go with TypeScript. This is basically known as implicit typing or implicit type inference. The compiler automatically determines the type of a variable based on its initial value. And if we wanted to just give it a type here, for example a string, hovering over it just gives us a string, and this would be known as an explicit typing or explicit type inference, which is when we tell the compiler exactly what it's supposed to happen or what the type is supposed to be. Since the variable wasn't instantiated, in this case this is usually the way to go. However, when working, for example, with HTML and DOM elements, which is one of the most common cases for any JavaScript code, we do get some quirky behavior from time to time. For example, I have added a button here with the ID of button main, and I will grab it here. Document.get element by ID button dash main. Yeah. Now, grabbing an element like this in JavaScript is perfectly fine, but if we hover over here, it gives us the type of HTML element or null, which is on point at a first glance. We're either grabbing the element or nothing if it cannot be found. But in our case, we definitively know that we're grabbing a button. I mean, an element, more specifically a button. So if I try to add an event listener to it, like so, well, first of all, I get this question mark over here. Oops, let's give it all the arguments so it doesn't complain. Meaning that, well, since button is potentially null, in some cases the event listener could not be accessed. Let's remove this and we immediately get the same error. That's where we use the exclamation point, which is known as the non-null assertion operator, and we use it here. We're telling TypeScript that, hey, I know we're grabbing something for sure from the index.html page where, well, the JavaScript file is linked. And it is definitely going to be an HTML element, and now when we hover over it, we do see that. However, we still don't have the definitive type of the element which this is, and this is a button. The HTML element is just a generic HTML element. It could be anything. So, to fix this thing, which also occurs when we use the .query selector or as well get elements by class name, we would have to explicitly cast this variable as the specific type we want. So to do that, we first of all have to make some space, then write the word as and the type we want to use. In our case, it's HTML button element. Now one click, if I just say button.innerHTML, I'll save this, open the page with live server, test it over here, and hey, it works. So far, we've only been using TypeScript in a singular file, and for the purpose of acquiring a new skill, there's nothing wrong with that. Grasping the fundamentals is quite crucial. However, once we get into the more complex concepts or we're working on a project, we soon realize that one lone file isn't going to cut it anymore. Therefore, we might want to branch out into a different file structure and keep our generated vanilla JavaScript code separate from the TypeScript we've been working on. To do that, we need to construct a configuration file for our TypeScript project, and the same terminal command would suffice here, albeit with a different flag. So in the project folder, I'll first open up the terminal from here. And then, well, let's stop this. I'll simply type tsc space dash dash init. Press enter, and this creates a tsconfig.json file in the root of our project directory. Now, opening this and browsing through it, we see a lot of different options with comments that are written here to simply explain further what the property is meant to be. These are all the possible properties we could use for the tsc command itself as well. The one that we're interested in is the out there command, or property in the JSON configuration object. I'll just uncomment this and add the JS as the name of the folder, and I'll save this. From now on, whenever I want to compile TypeScript into JavaScript, I don't have to do all of this things here, specify the files or anything. Just the command tsc would suffice, pressing enter, and the JavaScript folder has been generated with the correct file inside. And from this point on, this is the only thing that needs to be ever executed. The one type I've conveniently forgotten to mention up until now is the function type. In TypeScript, it represents any JavaScript function and is a broad type which encompasses all functions, regardless of their synchronicity, specific parameters, or return types. When we declare a variable with this type, we can assign any function to it afterwards. For example, like this. It's useful when we want to work with functions dynamically, like passing them as arguments or storing them in data structures. We might want to type it like so when we don't know the specific function signature in advance, which brings me to function signatures, which consist of two parts: the parameters thereof and their specific types, as well as the return type of the function. We do this when we know exactly how the function is supposed to act and what it's supposed to return. So I'll rework this greet here, and I'll create it using the function signature. So it'll take a name, which is a string, and it'll return a string as well. So now we'll assign it like this. Whoops, no return here. All right. This will cause problems for Node. However, to work with the TypeScript files directly, we will have to install another package. So I'll go to my terminal again, and I'll write npm install global. The package is called tsnode, and this will install the package tsnode globally on our system. Now if we run tsnode, but first save the file, const, let's just execute the function because it returns Peter, and we'll simply console.log the person. Save this, and if we execute it with tsnode, we get exactly what we're supposed to do. Well, this might be cute and all, TypeScript is quite a lifesaver when it comes to higher order functions. So I'll just create an array of numbers here, and the reducer function, which is supposed to sum all of them together. So let's sum all. First of all, I'm gonna write the function signature, which is gonna take an array of numbers and return one single number. And now I'll actually write the function itself. This is gonna be a.reduce, which again takes another function with two values this time, an accumulator and the value, both of which are numbers. And the function works by simply adding the value to the accumulator, console.log sum all numbers. When we execute it, it actually perfectly gives us back 10. However, it never hurts to actually type the reducer function as well. So we'll do that right now. Number, value number, and it returns a number. And the reducer function we can simply replace this whole thing here with this, save it, run again, and it works. This is generally the thing that is really helpful in TypeScript and causes a lot of bugs, problems and issues in JavaScript without any additional type checking fallbacks. In TypeScript, classes allow you to define blueprints for creating objects. They encapsulate data in the form of properties and behavior in the form of methods into a single unit. Suppose we have a class of person with two properties, first name and last name, and a method called introduce, which simply returns void and logs the introduction line to the console using both of these properties, like so. Now what we can do is instantiate an object from this class. Okay, now that we've done that, and once we instantiate the object, we can also see which of the properties we might access by taking a look at the object like this, person and dot. The IntelliSense will simply take care of the rest. We see that we can access both of the properties as well as the method of the newly created object. This is because that behavior is default and allowed out of the box, simply because we just declared the variable types for first name and last name inside the class without any other configuration. These are known as public variables and they can be accessed from anywhere. we have access to this object, and this is simply called is known as an access modifier. It's basically the same like doing this. Let's just get rid of the error. So this is default behavior, and simply omitting them would produce the same thing just fine. There are three other different access modifiers, but we only care about two more of them. They specify how the variables or class properties are supposed to behave when we try to access them. All four of them are, as such, public, protected, private, and read-only, but we don't care about protected all that much, as in my corporate experience I've actually never seen anyone use protected access modifier in a TypeScript class. Private properties, on the other hand, would only be accessible from within the class itself, and trying to access them from elsewhere, such as an instantiated object, would cause problems. Right now, when I type person.firstname, I don't have any problems here, but if I suddenly switch this to private, immediately I get an error that it is a private variable and only accessible within the class person, or here. So the only way we would be able to access this variable is through the introduce method, which uses both of these variables inside of itself, but there would have to be an extractor function for this, since it's not just printing the properties from the class, but it's putting them in a string and adding some additional things as well. The read-only accessor allows us to retrieve the property value in question, but strictly prohibits any modification. So if I change the accessor of last name to read-only, and I try to change it here, I immediately get an error saying that I cannot assign to last name because it is a read-only property. Though if I wanted to retrieve it like so, even from outside of the class, I could do it just fine without any problems. I'll just mention that the protected access modifier provides a middle ground between public and private accessors. We could, with the protected property, we could access a property from the class itself, as well as all of its derivatives, like subclasses and child classes, and things which extend it. They're accessible wherever we have the keyword extends, actually in the class declaration and the super call in the constructor. So we have a class, some properties, and a method. And if we hover over the object variable which was instantiated from this class here, it doesn't give us a type at all, but rather the class or the blueprint of the variable, in this case person. To define a shape structure of an object or a class, we use what is known as an interface. Simply stated, interfaces act like, I would say, contracts that specify which properties and methods an object or a class must have, and in case for methods, how they behave. They're powerful for maintaining consistency and ensuring code correctness. We define them using the interface keyword. And to use it with objects, the syntax is no different than when using it with types. So I'll simply create an interface for a person. so. So if we wanted to make another object, I'll just say person2. We'll basically use an interface like a type here. And now we can start declaring everything we need. Like so. This is fine. But aside from that, a class may also use the same thing. When it adheres to the structure defined by an interface, it is considered to implement that interface. And this is why we use the keyword implements here for this. Now apparently we have one error. Property first name is private in right. Let's just remove this. Now actually I want to add one more addendum here. Variables and methods could also be private in an interface as well, or read-only. We could do this as well, but again, we don't want to cause any more breakings. Another thing we have here is this question mark symbol, which I've placed on the method to make sure that it is optional, or in other words, that it can be undefined and doesn't always have to be there. All in all, interfaces are ideal for describing object shapes, defining contracts for external libraries, and ensuring consistency across classes, since they enhance type safety, promote good design, and make the codebase more maintainable. And while having interfaces on classes is cool and all, they're only ever useful in narrow predefined situations. They apply strict rules to which everything must adhere, which is absolutely phenomenal for object-oriented programming, but sometimes we need that extra layer of flexibility in order to work with data on a larger scale. Enter generics. Generics allow us to create reusable components that work with a variety of types and provide flexibility by allowing us to write code that can handle multiple different data types without sacrificing type safety. Or, in other words, without casting everything as any. Consider the function that takes in an argument and returns the same, such as this one right here. Now, obviously, this is throwing an error because the parameter has implicitly an any type. Because it's dynamic in TypeScript, again, the compiler is complaining, and on top of which this isn't very useful for type safety. At this point, using the function in a project would break any TypeScript functionality due to its unpredictability. Generics allow us to pass the data type in the same way that we would pass arguments to functions, kind of like the utility types we've seen in the first video, like awaited, partial, required. All of these are generics in a sense, but by changing our function to something like this, generics are usually denoted with the capital letter T, but I will write the word type just to be on the safer side here, and for everything that I'm doing to actually make sense. The error now goes away. The type here in the angle brackets is generally, as I've said, abbreviated to capital T, and it doesn't actually have to be either type or capital T. We can say generic as well. Something, doesn't matter, absolutely. It can be changed or substituted with anything else once we end up using the function. So I'll demonstrate it quickly. if I write give back here and call it with some random number, hovering over it, it just gives us that number as the specific type for everything here, and that is what it's returning. But we can change the type to make it a bit broader, to like a number here, and it'll take in a number as an argument and also spit it back out. The same can be done with a string or boolean or object or any other different type. This is the reason why these are called generics. They emulate and mimic a random type, but can be substituted out when the time is right. The best part is we can also use this with interfaces and classes as well, as long as we don't forget to tell TypeScript what the generic type will be. The last thing I will be talking about is the enumerators. Enums define a set of named constants gathered under a single namespace, or a variable name. TypeScript provides numeric and string-based enums. Numeric enums assign incremental numeric values to enum members starting from 0, like everything in coding does. Say for example you're making a game and capturing the player's input. You would encapsulate the movement directions in a single enum like this. So we have up, down, left, right. Now these all evaluate to numbers. This is 0, 1, 2, 3, and we can prove this by going to the console and logging everything once, left, right. Up, and if we come over here, execute our TS node, we get up is 0, down is 1, left is 2, and right is 3. If these were to be saved in a database, the value would be one of these numbers, which fall under this. And later in code, using this enum, wherever it is stored, we would see what the value of the number actually means. String-based enums, on the other hand, allow explicit assignment of string values to enumerators. I've found them phenomenal while working with Redux types, as numeric enums could usually have a value collision and accidentally mess up, and using the wrong one in a dispatch function could break the entire Redux store, which is even scarier when you're using Redux persisters. Enums are great for documenting intent. They make the codebase more readable by providing meaningful names behind the values, on top of which they also create a set of distinct cases, and enums help define a finite set of options. Anyways, that concludes the video. Thank you for watching. Goodbye world, and have a nice day.